So, okay, today we are back with the larger diesel heater now, the Hcalory. I don't know what model number it is, because the model number that it shows on eBay and Banggood doesn't match the number that's on here. So the model on here is an XMZ-D2, and this is the larger heater body, the big. We've got the 6 kilowatt. We'll just call it the 6 kilowatt. So we're going to do all the tests today that we didn't do in another video and that have been suggested for testing. In this part of the video, I'm going to run through the tests I'm going to do. If you don't want to watch this bit, by all means, skip ahead. That's what the skippy buttons are for. You can skip ahead to we're actually doing the thing. Now, one of the first questions asked was, or someone stated that it was said it was the exact same size, or the specifications on the eBay link auction thing description were just the same size as a normal heater. This is not the same size as a normal heater. This is the outer case of the standard 4 kilowatt Triclix one that we had. And well, actually, if I just sit it next to it, all right, you can't see the other side, but is it the same size? Wait, it's fractionally longer. I mean, like fractionally longer, because the way they've done it, I wish it wasn't set up the way it is, but basically there's a lot of space inside your heater between where your heater body ends and where it actually gets near the end cap. So what they've done is made a new end cap for it, and the heater fills in the space in the end cap better. So basically your heater comes right out to the very, very edge. So they managed to get more heater body in a very slightly longer and slightly changed shape end piece. So the metal body's longer than the other one by quite a bit, but they managed to smoosh it into this bit by just changing the shape and the end of the thing and filling the space better. So for my test setup, because we have the Hcalory here first, we will do it first. I've removed the ducting from the end, so I'm just going to get a airspeed measurement directly on the end. I've drilled a hole in the case and actually poked the probe in so it'll stay in one spot, and I'll drill a hole in the normal 4 kilowatt the same. I'm going to make them both exactly the same to try and get the most, well, not accurate measurements, but comparable measurements. And so we'll have the exhaust, the air filter, they'll all be the same. The exhaust, I have attached the TPI DC710 gas analyzer, so we'll get exhaust gas temperature and the carbon monoxide emissions from the exhaust on both heaters, which we'll be able to compare. The air intake will just be the standard air intake, and I'm going to just use the same pump for both of them because they're supposed to both be a 22mm pump, so we'll just keep the same pump, the exact same pump, and run it that way and have the same pump. And I've got it attached to the oscilloscope on the laptop, and that's going to give us a hertz reading for both setups, and I'll be able to compare the hertz because we haven't got scales to weigh the fuel yet, but we can use the same pump and use the same hertz readings, and even if they're wrong, they'll be the same wrong, if that makes sense. Like, even if it's not pumping 22, it's pumping 8, it'll be pumping 8 for both heaters. You know what I mean? It'll be the same amount of wrongness, but it'll be comparably wrong, which is what we want. So that's on the oscilloscope, that works, so that'll be able to count the hertz for us. And, well, basically I'm going to run the heater now and do the measurements and then write it down on the whiteboard, and then I'll bring you back. Well, I have now run both heaters, the standard 4 kilowatt and the Hcalory, I'm just going to call it 6 kilowatt from here on in, because that's what I've written down in my dossier. Yes, I have compiled a dossier of my findings and results. Let's go through all the number crunching first together, and then we can talk a bit more about the heaters. Hopefully I'll be able to put some of this on screen rather than you trying to read the document as I'm trying to read it. Right, we're going to start with the Hcalory 6 kilowatt. So, briefly, I measured a hot air output of 4.874 kilowatt hours. So that is the hot air coming out the hot end. I measured it at 4.874 kilowatt hours. This is more than we had in the previous video because my testing was better for this. We'll just briefly run through the numbers. So this is for maximum power, I should say. This is at max. Maximum power, 4.8 kilowatts or 4.9 kilowatts. Airflow out of the orifice at the end was 8.5 meters per second. This gives us 100 and... does anybody mind if I just kind of like round up for the purpose of this video? I'm going to round up. So 166 cubic meters an hour. So if we take their 166 cubic meters an hour, that gives us 214 kilograms of air pushed through the heater every hour. Please turn page. And if we go into the online calculator, where we tell it we had 214 kilograms of air. The air started at 8 degrees and it finished at 89 degrees, giving us a change in temperature of 81 degrees, and that equates to the 4.874 kilowatt hours of hot air being produced. Now, onto the amount of diesel that it consumed. So at max power, it used 491 millilitres of diesel per hour. 491 millilitres is 421 grams of diesel per hour. The specific energy of diesel's 45.5 megajoules per kilogram. So 45.5 times 0.420. The diesel heater used in fuel 19.11 megajoules of diesel, or 5.3 kilowatts of diesel. So we burned 5.3 kilowatts of diesel to get 4.8 kilowatts of hot air out the end. And just in ancillary information, at maximum power we had 46 parts per million, 12.5% CO2, and the exhaust temperature was 424.7 degrees C. Now, onto the minimum settings. So down at minimum, the pump ran at 1.9 hertz. So 1.9, you go through all the numbers, 0.22 milliliters, times 60, times 60. 151 millilitres an hour of diesel, which I didn't need to tell you that's now because we're doing the airflow. But anyway, airflow, 4.3 meters a second gets you 84 cubic meters. 84 cubic meters is 108 kilograms. 108 kilograms started at 10, final temperature 54, gets you 1.339 kilowatts of output on the low side. So the low power hot air output was, we'll just call it 1.3 kilowatts. And as I said, with the diesel, we used 151 millilitres, which is 130 grams, blah, 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 5.99 megajoules, 1.64. So we used 1.64 kilowatt hours worth of diesel to get 1.3 kilowatts worth of hot air. Ancillary information, on the low side, it was 141 parts per million of carbon monoxide. That was pretty terrible. 6.4 CO2 and exhaust temp 225 degrees C. So when it's burning hard and hot, it's absolutely fine. I mean, like, what did I say for carbon monoxide? 46. It's not great, but I mean, it's not the terrible level of the low side. So as other people suspected, with the bigger heater running lower, it runs worse. So big heater running low, not great. So that was the big heater. That was the 6 kilowatt. Now, for comparison, we have the 4 kilowatt, and we'll talk more about the heaters at the end to give you more information on them and their comparisonness. So the 4 kilowatt managed a maximum hot air output of 3.417 or 3.4 kilowatt hours of hot air. Again, we did the maths. Duct size, obviously it's the smaller duct on this one. 159 cubic meters an hour, which is 200 kilograms of air an hour. 200 kilograms, started at 10, finished at 69, gave us a hot air output of 3.4 kilowatt hours. We used, what did I say, 435.6 millilitres of diesel, which is 370 grams, or which is 6.84 megajoules. So it used 4.68 kilowatts worth of diesel to get us 3.4 kilowatts of hot air. That's not particularly efficient. But it did have a nice 19 parts per million of CO2, 10.1% carbon monoxide, and the exhaust was 440 degrees. So there's the problem with that, is that's a really, really hot exhaust output. So most of the nearly 5 kilowatts of diesel it was burning. It's ending up as hot waste air going out exhaust rather than nice heated air. Now, 4 kilowatt on minimum. Now, this particular heater was able to output 1.35 kilowatts of hot air on its minimum settings using 126 millilitres an hour of diesel. We'll go through the air again first. 35mm duct, 58 cubic meters an hour, 58 cubic meter hours is 75 kilograms. 75 kilograms, starting at 6, because I filmed this the next day when it was cold, because I wanted to get the cold of this heater cold so I could do an accurate cold side, which took me into the next day. So 6 degrees intake temperature, 70 degrees output, gave us 1.3 kilowatts of hot air output. Now here's where it got a bit interesting. So as I say, it used 126 millilitres of diesel, which is 5 megajoules, which is 1.39 kilowatt hours of diesel it burned to give us 1.35 kilowatt hours of hot air. Now look at these readings. 5 parts per million, 7.6, 5 parts per million of carbon monoxide, 7.6 of CO2, and exhaust temperatures 215. So this heater ran really, really efficiently at its lowest setting, and I have no idea why. But we'll come back. Right. So now on to the heaters themselves. Right, that was information. Basically, yes, this heater is bigger and outputs more hot air at max. If you run it on low, it's fucking awful. It's terrible running on the lower size. Now, this Triclix heater is fucking bizarre. At first glance, you'd think, oh, that's the standard controller. You can just go in and change the settings. Oh no, you can't. See this spanner? Yeah, this button almost does nothing when it's running. There's no settings menu. There's nothing in there to fiddle. Pressing OK just cycles through the temperature sensor on there, the housing temperature sensor, and like your power level and your battery level. And this has power levels between 1 and 10. Up and down changes it between 1 and 10. So when I was doing the testing, maximum's 10 and minimum was 1. Usually the old diesel heater with the blue displays, orange display, and then the red display, that doesn't seem to bear any relation whatsoever to what temperature the housing in this heater is. This Triclix one is also really weird. So it does the usual startup where turns the glow plug on, pumps the fuel in, and then runs for a little bit, and then it cuts the glow plug. Now, every other diesel heater I've tested has increased the pump speed and the fan speed and got the burn chamber temperature up to hot and up to like over 120 degrees or thereabouts, and then throttles back to the lowest setting. This one doesn't. This just runs it low, and it nearly flames out every time it starts. You can hear the moment when the glow plug goes out and the flame nearly dies, and it just slowly pumps fuel, very, very slow. Obviously at 1.2 hertz, it's just slowly pumping fuel, and the fan's running slowly. That's why it took me into the second day to get a low side reading, because it took it so long for the temperature of the burn chamber to come up and stabilize, because it's only coming up like a degree a minute. And it needs to get up, but I think on its lowest setting it plateaued. I want to say the burn chamber temperature, because the sensor does the housing. The housing temperature stopped at 79 degrees. I let it go up to 79 and it stayed there for a few minutes. I thought that'll be fine. That's it now, as hot as that's going to get for the 8 degrees of air it's intaking. So that, I don't know if that's why it runs really efficiently on its lowest setting, because once it gets there, it can just stay there and just maintains this nice ticking over of temperature. But that's that. That's the Triclix. That's the weird heater that is that. So back to the Hcalory big one. Someone, I think I might have said this before, they said that it had the same size in the specs as a smaller one, and it clearly, can you see from, you can roughly see. These are lined up, and that, the end cap there and that bit is ever so slightly longer than the other one. It's not a huge difference. We're talking like like that. It's only that much bigger. But it is bigger. It is a slightly bigger because they've made the end cap. Well, hopefully you can see zoom in to the end caps. So you see the 4 kilowatt end cap there. It's not very big. It's slim there. You can see the edge. And if we go over to the other one, you can see how much bigger that end cap is than the standard one. I'm both in the shot at the same time. Look. Big one. Smaller one. So that's where it's... Everything else is the same. The body housings are all the same length. All that's the same. Everything else. It's just this. They changed the end cap for the bigger end orifice opening and to make it slightly longer to get the slightly longer heat exchanger in as well. Other things people asked if there's any tuning settings in this, the Hcalory controller. Not that I've found so far. I've got my Bluetooth to connect it. The Pixel 7 Pro connected first time to this, and I was able to turn it on and off with the Bluetooth. That wasn't a problem. But as for tuning, it says in the manual you can go into the extra settings bit, but going into extra settings, nothing I have changed has ever stayed. You can fiddle with them, but nothing in there actually locks. I don't know why, because people say there's like the fuel pump size and there's like altitude and things, but none of those appear to be editable. The only one you can change and actually really stayed is the fuel tank size. I think that's about it. But yeah, the Bluetooth app worked fine. It just connected and away it went, and able to turn the heater on and off. I still haven't changed the language from Chinese though. It just tells you. I don't know what she's saying, but yeah, I'm sure I've seen somewhere. It might have actually been on the Hcalory website manual, the extra settings menu you can get into. But it didn't do much. Well, to wrap things up, this the Hcalory whatever version is, the numbers on there as I say don't match what it lists online. The 6.5 to 8 kilowatt, no, the 6 kilowatt to 8.5 kilowatt is a bigger heater, does produce more hot air than a standard 4 kilowatt, but on its low side it appears to run, well, rather inefficiently at its lowest setting compared to a standard heater. Then again, what's a standard heater nowadays? I mean, how many of these 4 kilowatts have we seen? How many controllers are we up to now? They're all incompatible with each other. So many motherboards, so many other things. But anyway, if you have any comments, questions, or anything else to add or to question about the big heater, please put them down below and I'll answer them, or perhaps even other people will be able to answer them now if they've bought them. And that's us. Thanks for watching.